Good afternoon, everyone. Welcome back. I hope you had a nice break and an enjoyable Easter weekend with your family. Today we're moving on and we're looking at lesson 30.03, dealing with applications of sine and cosine functions, and this lesson can be found on page 9 of your lesson handout. A lot of the time in nature, and we'll see some situations where they are not naturally occurring events, but a lot of the time in nature, there is some quantity that follows a periodic change. What does that mean? It means there's something that over time increases to a maximum value, decreases to a minimum value, and then increases to a maximum, and then decreases to a minimum, and it keeps repeating that process regularly. So there's a certain period of time that it takes for the event to repeat. And if we were to graph that quantity on a vertical axis and time on a horizontal axis, we would get a sine or a cosine curve. Now, a couple of things that's important in today's lesson when we're solving these problems. The first one is you always want to solve these graphically. Normally, you know me, I would normally say to you, I'm going to show you how to solve it graphically, but you do need to know how to solve it algebraically. Even if we were still having a diploma exam, and even if we were still having unit exams in our classroom, you would never be expected to solve these problems algebraically. And believe me, you don't want to try. If you do try to solve these algebraically, you're going to open up a can of worms, which is going to be very messy. The other thing is you always want to work in radians. I've got, unless you're told otherwise, but I've never ever seen anybody told otherwise. It's always radians. Let's take a look at the first example. It gives you a function that describes the depth of the water in a harbor. So let's just stop and think about this. There's a little harbor, which is an inlet in the land, and the water in that harbor goes up and down regularly. Why should it do that? Because there are these things called tides, and when the tide goes in, the water from the ocean goes into the harbor, filling the harbor up, and the depth of the water goes up. And as the tide goes out, which is called low tide, the depth of the water in the harbor will decrease. And tides happen regularly. So here's the function. Depth of the water as a function of time equals -8 multiplied by the cosine of pi over 6 times t plus 18.5. Now some of you might be bothered by the d of t notation. If that does bother you, just think of d of t as simply being d. It's the depth in meters, and t is the time in hours after midnight. Now you're asked to determine 3 things here. You want to determine the period of the function. You want to determine the minimum and maximum depths of the function. And I'm going to tell you that there's a reason why I'm asking you to determine these things. You need to determine them to put the proper window settings in your calculator. If you don't know the period and the minimum and maximum values of y in these problems, you're going to be fumbling around trying to get a good representation on your calculator of what the graph looks like. You need these things to look at the graph properly. So even if I didn't ask you to do this in A, and instead I simply said to you, use that function to find the depth of the water at 2:50 in the morning, you still need to find the period and the maximum and minimum values of the function in order for you to answer the question. So how are we going to find the period? We've learned that the period of the function is 2 pi divided by b. And when we look up here, we can see that b is the coefficient of our horizontal variable. It's pi over 6. So we can put pi over 6 in for b. We know that when you take one quantity, like 2 pi, and divide by a fraction, the rule that leads us to the answer is you take the numerator, which is 2 pi, and multiply by the reciprocal of the fraction. When we do that, we can see that the pi's cancel, and you're left with 2 multiplied by 6, which gives us 12, and now we know that the period is 12. The horizontal axis is measured in hours, so the period is 12 hours, and this starts to make sense. Why should the depth of water go up and down and back once every 12 hours? Because the tides go in and out and back every 12 hours. Now, how are we going to find the maximum and minimum values of the function, which is displacement or depth? We're going to have to take a look at the values of A and D. We can see that A is the coefficient of the cosine function, which is -8, and that becomes important because it tells us the amplitude is 8. We can see that D is 18.5. That becomes important because it tells us the vertical displacement is 18.5. These numbers are important, the amplitude and the vertical displacement, because they allow us to get a visual representation of where the graph is located vertically. If the vertical displacement is 18.5, then the middle of the graph will be at 18.5. If the amplitude is 8, then that means that 8 below the vertical displacement and 8 above the vertical displacement will be the places where the graph is confined to. There will be a maximum and a minimum value. And the maximum value will be 18.5 plus the amplitude, which gives me, I believe, 26.5. And the minimum value will be that 18.5 minus the amplitude of 8, which gives me 10.5. And again, it's 8 up to get to the maximum, and it's 8 down to get to the minimum. So now we know, everybody, if you set up window settings on your graphing calculator that take into account those vertical numbers and go up to 12 hours for x, you will be able to see one complete cycle of this cosine graph. So let's take a look at what it's going to look like. Well, I guess we should answer the question first. The minimum displacement or depth of the water is 10.5 meters, and the maximum is 26.5 meters. Let's take a look at B. We're simply going to use our graphing calculator here to answer, well, B and C. I want you to notice in B, though, before I get to the graph, I want you to notice that in B, you were given a time, and you were asked to find a depth. Now, the time is 2:50 in the morning. And 2:50 in the morning is not 2.5 hours, it's 2 hours and 50 minutes after midnight. So we need to figure out what 2 hours and 50 minutes is in hours, because the function works when the time is in hours. Well, I'm going to take 50 divided by 60, because there's 60 minutes in an hour, and we get 0.83 repeating, and that means that if I add the 2 to it, the time is 2.83 repeating. So going back to my point here where I have this table, in question B, you are given a value of t of 2.83 repeating, and that's in hours, and you are asked to find the depth of the water. However, in question C, you were given the depth of the water, which is 25 meters, and you were asked to find the time. In B, you're given an x and asked to find y. In C, you're given a y and asked to find x. On your calculator, these two questions are answered in two totally different ways. You use a different procedure for each. So let's load up that graph. We have y equals -8. Then cosine And then I have pi over 6 times t. There's nothing wrong with putting that. I don't like how that looks. That looks, even though it isn't, it looks like pi over 6x. I prefer, and it doesn't really matter, but I prefer to put pi x over 6. And then we close the brackets and we add 18.5. Now we have to do a couple of things. One, we have to make sure that our calculator is in radians, and my calculator is in fact in radians. The second thing we need to do is enter our window settings. I'll remind you that we said we want to go up to 26.5 vertically and we want to go over to 12 horizontally. So for x, I'm going to go from 0 to 12, and I'm going to put a tick every 2. For y, I'm going to go from 0 to, I'm going to go up to 30. I always like to go up a little bit higher than the maximum value. And let's put a tick every 5. The x scale and the y scale don't really matter. Now if I hit graph, I end up seeing a nice curve. If you didn't know what the period was and the maximum and minimum values of y were, then you wouldn't be able to get to this stage. So how is it we answer now question B? All we do when we know x and want to find y is we hit the trace key, which is at the top of your calculator, and then you enter the x coordinate and then hit enter. .8333333. It said invalid dimension because I was entering 28.3 repeating and my calculator viewing screen is only going up to 12. So the answer to question B is 17.8 meters. Now, how is it that we answer C? Unfortunately, there is not a function on your calculator that allows you to enter y and calculate x. So what we're going to do is go to our y, where we entered the function, and we're going to enter a second function of y equals 25. And our goal becomes to find the point of intersection. Now, there are 2 points of intersection, but the question says, when does the depth of the water first reach 25? So we're interested in that first point of intersection. You go to your calculate menu, which is second trace, choose intersect, scroll over so that you're close to that point of intersection, and hit enter 3 times. And we can see that it's 4.8 hours after midnight. And if you were ambitious, you could convert that 4.8 hours to hours and minutes, but I'm not really that interested in this. 4.8 hours after midnight. And that's example 1. All right, let's take a look at example 2. Before I read the question with you, there's a mistake. That should not be the function. The function should be frequency as a function of time equals 85 cos pi over 5t plus 355. So if you need to pause the video to write that down, by all means do so. What this question is about is an alarm, and when the alarm sounds, the frequency oscillates up and down between 2 values following that function. 85 cos pi over 5t plus 355, where f is the frequency in hertz, the frequency of the sound, and t is the time in seconds. The first thing that you were asked to do is to determine the period, minimum frequency, and maximum frequency. Pause the video, calculate these 3 things on your own. It should only take you a minute. You can look back at the first example for how we did that. and then unpause the video and I'll talk about what the three numbers are and how we got them. So the period is 10 seconds. It's a measurement of time in seconds because t in this function is measured in seconds. You get the period by taking 2 pi divided by b, 2 pi divided by pi over 5. When you divide by pi over 5, you have to multiply by the reciprocal, and when you do that, the pi's will cancel. You'll be left with 2 times 5. The minimum and maximum frequencies are found by looking at the value of d, which is 355 hertz. That's the vertical displacement. The lowest value of the frequency would be that vertical displacement minus 85, because 85 is the amplitude. And if you subtract 355 minus 85, I believe you get 270, and that is in hertz. The maximum frequency is going to be what you get when you add 355 to 85, which I believe is 440 hertz. Before we move on, I just want to double check those two numbers. I think they're okay. Now let's take a look at the next question. The next question says, Mr. Wei cannot hear frequencies below 400 hertz. So when the alarm is going, what percentage of the time will I actually be able to hear the alarm? Well, what you're going to have to do here is graph the function on your calculator. Now, I've already gone in here and I've set up the window settings. I went from 0 to 10 for x because the period is 10 seconds. And for y, I went up to 500. And the reason I went up to 500 is the maximum frequency is 440. Now, I've also already put in the two functions, 85 cos pi x over 5 plus 355. And the other function I put in is y equals 400, because that is kind of my threshold hearing. If the frequency is above that, I can hear it. If the frequency is below, I cannot. And when I graph it, I get this image. And what this is saying, everybody, in terms of the question and my hearing, is that I can hear the sound here, 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 and I can hear the sound over on this side, but all of this part that's below that line of 400, my hearing is not capable of picking up that sound. So I don't hear anything there. And you can see just by looking at this that it's certainly less than 50% of the time I can hear things. Your job for me right now, and then I will do it with you after you do it, but you need to find the point of intersection on this side and the point of intersection on this side. Then we can worry about determining what percentage of the time I can hear this thing. So when you find those, resume the video. So how are we going to find those? Well, it's really not that difficult. You're going to go to second trace, which is your calculate menu, choose intersect. Whichever point of intersection you want to find the coordinates of, just go closer to it. For whatever reason, I happen to be very close to the one on the left right now, so when I hit enter 3 times, I get 1.61 seconds. And rather than me writing that down, I will just save that over here. When I find the point of intersection on the other side, I repeat the process, but when I get to the stage where I'm ready to hit enter 3 times, I want to scroll over to that side. Now, I can't hold the key down because my smartboard will think I'm right-clicking, so I'm tapping repeatedly, but on your calculator, you can just hold the key down. As long as you are closer to that point than the other, that's good enough. Then we hit enter 3 times, and the point of intersection here is 8.38 seconds. That means that I can hear from 0 seconds up to 1.612 seconds, and I can hear from 8.388 seconds up to 10 seconds. Don't forget, this goes up to 10 seconds. So that's a total of 1.612 seconds that I can hear. And to find out what length of time I can hear in this interval, I guess I would have to take 10 seconds and subtract 8.388. Which is this number. So if I take 10 minus that answer, I can hear for, well, that kind of makes sense. There's a symmetry to this function, 1.612 seconds. And that means in the whole 10-second interval, I can hear for 2 times 1.612 seconds, which is 3.224 seconds. Now don't forget, that's in a 10-second interval. So if I want to find the percentage of time, I can take the 3.224 seconds, divide by 10 seconds, which is the entire interval, and multiply by 100. And I get a paltry 32% of the time. So I can only hear the alarm for 32% of the time when it's on. We have one more example we're going to look at. All right, let's take a look at example 3. This is kind of the opposite of questions 1 and 2. In 1 and 2, you were given a function and asked to answer questions about the situation. In this question, you're given information about the situation and asked to determine the function. So what's the situation? A Ferris wheel at Westworld Theme Park has a diameter of 30 meters. So from the bottom of the ride to the top of the ride is 30 meters. It travels at a rate of 6 revolutions per minute. The bottom of the Ferris wheel is 4 meters above the ground, and this is where the ride starts. Joel and Ellie start the ride at the bottom. The question is, what's the equation of the function that we can use to determine the height of Joel and Ellie in terms of how long they've been on the ride? Well, I guess what it boils down to, everybody, is we need to know the value of A, B, C, and D in order for us to write out the equation of the function. And the equation of the function will either be a sine function or a cosine function, and it doesn't tell us which one we have to do. So that's entirely up to us. What I've done is I've reproduced the diagram here, but on the right of it, I've got a grid or a graph. I've got a vertical axis, which is going to be showing me Joel and Ellie's height above the ground, and I have a horizontal axis, which is showing the time over which the ride has been in operation. And I've got 3 guidelines there. Just like any other sine or cosine function, there is a maximum, a minimum, and a middle. And since they start the ride 4 meters at the bottom, the minimum value of their height would be 4. What's their maximum height? Well, their maximum height is going to be 30 above 4 because you're told in the question the diameter of the wheel is 30 meters, which means that this must be 30 plus 4, which is 34. To find the mid value, we could either average those 2 points to find out where they are halfway from the bottom to the top, or we could say, since the diameter of the wheel is 30, that means the radius must be 1/2 of that, which is 15. So the middle of this graph must be 15 above the lowest point. 15 plus 4 is 19. As a double check, that middle point should be 15 below the highest point. And sure enough, 34 minus 15 is 19. Of what value is all of this? Well, we know now that the amplitude, looking at this graph, is equal to 15, which means A is either 15 or negative 15. Lowercase a is either 15 or negative 15. We also know that the vertical displacement is 19, because the vertical displacement is always where the middle of the graph is. So we basically have two of our parameters. We have A, which is either positive 15 or negative 15, and we have the vertical displacement, which is 19. Now we can find B. B is not that difficult to find. There's a couple of steps to it, but we know how to do this. B is related to the period. I'll remind you that B is equal to 2 pi divided by the period. So how can we find the period? Well, it says that it goes around 6 revolutions in 1 minute. I'm going to choose to work in seconds. We know it goes around in 60 seconds, 6 revs. Well, the period is the time it takes to go around 1 revolution. So what we're solving is that little equation. It's a ratio equation, and we can solve that by cross multiplying. 60 seconds over 6 revolutions equals the period over 1 revolution. You're going to discover it's 10 seconds. So the period is 10 seconds. And I suspect that many of you would have just said, well, if it goes around 6 times in 60 seconds, then the period is 10 seconds. We can throw that in to our formula for B, 2 pi over k, which is 10 seconds, and 2 over 10 is 1 over 5, so we get pi over 5, and now we know B. The tough part now is finding C. But let's sketch the graph. We know that they start at the bottom, and in a 10-second period, they're going to end up back at the bottom. So if I put 10 seconds here, and I divide that into 4 chunks, just eyeballing it, we know that they start at this location. They're going to go up. Then they were going to go up further. I'll use a different color here. They start at this location. They go up. Then they're going to peak at this point, so they continue to go up. Then they're going to come back down to the middle here. And then they're going to reach the bottom at the end of 10 seconds. So this is a rough sketch of what the ride looks like graphically. One thing I notice is that cosine, if we choose cosine, cosine normally starts at the top, but they start at the bottom. So I can get away in this example by simply choosing a negative value for the parameter of A, which will flip that top point to the bottom, and then I can say C equals 0. I'm going to fix A to be negative. What that does is solves my problem of having C being equal to 0. And then really everybody, we're basically done. We write out the equation of the function. Joel and Ellie's height equals A, which is negative 15, multiplied by, we settled on cosine of B times the time plus D, which is 19. And what you can certainly do is, on your own time, enter this into your graphing calculator along with the appropriate window settings, and you will see that it matches their ride perfectly. So you have a number of questions that you're working on related to this. Remember that you are looking at using the period and the maximum and minimum values of the function so that you can get the right window settings. Remember that you were solving these all graphically, not algebraically. And remember that you have to be in radian mode for all of these problems. So good luck with them. Tomorrow we will be having Google Hangouts, so if you have problems with these, drop by and I'd be happy to help you out with them. In the meantime, have a great rest of the day, and we will talk to you later.